red light on, green light on, red light off, green light off. Alright, it's working. We got a Raspberry Pi 5 here. In this video I'm going to show you how to control outputs using OpenAI's Whisper C++ model. You can run this on a Raspberry Pi 5, or even with a couple adjustments, run it on a Pi 4. The Pi 5 will do up to the small model, while the Pi 4 will just handle the tiny model. And this video assumes that you've already installed Whisper C++. I'll put the previous video in the description along with the software, GitHub link, all that stuff. And this also assumes that you've installed the, here's the GitHub. This also assumes that you installed the gpiod libraries. Here's the hardware setup. We have output 25 here in yellow. This is 10 pins up on the right hand side of the 40-pin header. This goes to the green LED through a 220 ohm resistor, and then back through this orange wire here to ground. And ground is 3 pins from the end here on the right. And then similarly, the red LED is connected here to output 24, which is 12 pins up from the right, so 2 pins up from the output 25 there. With a setup like this and a motor hat like this, you can control all kinds of things like a little motor, a buzzer, so on and so forth. And the possibilities are endless, really. I mean, you can customize this to do whatever you want. What's also nice about this setup is there's no wake words. Like, you don't have to say, "Okay Google," or "Alexa do this," "Alexa do that." It'll just work as long as it's running. There are 2 major adjustments that need to be made. First is changing the Makefile to include a link to the gpiod library, and that's on line 349 here. And the key is to include this at the very end, -lgpiod. Otherwise, if you don't do that, you're going to get a linking error. So that's the first change that needs to be made. And then the second change that needs to be made is you go to Examples, Stream, and then you take the old default stream file and back it up, old, or whatever you want to do, just so you have it, and then copy this new stream file to where the old one used to be. And I'll show you the changes in the new stream file here. There's 4 changes, and what I did was, wherever there's a change, I added a comment with 3 dashes here, and you can use Control F to find those 3 dashes easily. So the first part here is adding new libraries. Then down a little further, there's the main function, and this is the hardware functionality. So here are the outputs. Now, of course, you can add more outputs or do whatever you want here. Now, one of the keys is for the Pi 5, you need this to be GPIO chip 4. But for the Pi 4, it needs to be GPIO chip 0. So just a heads up there. Then further down, where the fun part happens, is down here where you make your special phrases. For example, you say green light on, And the model might output slightly different variations. For example, this one has a capital G, this one here has a lowercase g. Sometimes there's a period, sometimes there's no period. So you put these all in parallel here, and then you have your output. Here's where you set your output high, so on and so forth. So the cool thing here is you can make this do whatever you want to do, and you can put any phrase you want to put in here. So say motor on, you could add motor on. Here's an example, all lights on. This turns all the lights on. And then at the end, close the chip. So those are the 4 changes to this file that I posted on GitHub. Now once you made those changes, then you got to compile everything, make JStream, and to know that everything's linked properly, you'll see here at the end l-lgpiod. That means you're getting that link to the gpiod library, which is great. Now if this isn't linked properly, I'll show you what'll happen in a minute. Now, if you didn't include that line in the Makefile, the -lgpiod, you're going to see it's not included here in the compiling process, and then you get all these errors. So make sure you do that, otherwise it's not going to work. You can run this on the Raspberry Pi 4. If you do, make sure you change gpiod chip 4 to 0. So this just gets changed from 4 to 0. And then you can run it. Now if you're having some kind of performance issues here, then you can add this NF at the end. It's not going to be as accurate, but I'm just throwing it out there. That's no fallbacks. On the 4, Raspberry Pi 4, make sure you run the tiny model here. So that's it, let's run it. Testing, 1, 2. Red light on. Red light off. Red light off. There we go. It's not always super accurate. Sometimes it does like do a repeat here, which doesn't work. The Pi 5 is more accurate in general. On the Pi 5, we can run up to the base model and even the small model here, but on the Pi 4, stick with the tiny model. So let's run it. The nice thing about this is that all the computation happens right here on the Pi 5. There's no API calls to the cloud. There's no, you don't have to be connected to the internet. This would work anywhere in the world, just standalone. It's all being done on edge, so it's really cool. And it's pretty accurate here with the base model and fairly quick. It's a lot better than on the Pi 4. All lights on. Well, thank you for watching, everybody. I hope this will help you in your projects, and take care. All lights off.